So let's continue looking at our investigation as they relate to quadratic relationships and their curves. So we know again that all exponential relationships and their curves. So we know that all exponential relationships are written in the form of y equals a times b to the exponent x. Okay, and so we already talked about how a indicates the y-intercept. Okay, so A tells us what the y-intercept is going to be on the graph. So now we've got to figure out, well, how does the B value affect the graph? So if we look at numbers where the B value was greater than 1 or bigger than 1, this here means bigger. Okay, so when the B value is bigger than 1, i.e. not equal to 1, then what ends up happening is the graph goes up. It's increasing in value. So it is increasing in value. However, if the B value is between 0 and positive 1, then the graph looks something like this. Okay, so it's going down from left to right, and that means it's actually decreasing in value. Okay, so generally speaking, the bigger the B value is, the faster the rate of increase. Okay, the smaller the B value is, the faster the rate of decrease. Okay, so let's take a look at 6 equations and 6 graphs and try and match them up based on what we know. So let's take a look here. We've got y is equal to 3x. So I know right off the bat that the a value is 1. This could also be written as y is equal to 1 times 3 to the x. So my a value is 1. So automatically I know that it has to be one of the two graphs on the left-hand side here. It also says that my b value is 3. That means that if I substitute 1 in for x, 3 raised to the exponent 1 is going to give me that point right there, which means that this graph here, this red graph, that this is y equals 3 to the x. The next example that I'm going to take a look at here, I've got an a value of 5, okay, and I've got a b value of 2. So I need to find one of the graphs that has a y-intercept of 5. Well, this here has a y-intercept of 5 right there, and I know that at 1, I'm going to get, at an x value of 1, I'm going to get y equals 5 times 2, and that's going to be 10. So that means that this purple line is going to be y is equal to, this purple line is going to be y is equal to 5 times 2 to the exponent x. The next example that we have, we've got y is equal to 9x. Again, the a value isn't written, so we presume that it's going to be 1. So that's y is equal to 1 to the 9x. So we know the y value, or rather the y-intercept is going to be at 1. So that's going to be one of those two. And we know that the rate of increase is 9. So when x is equal to positive 1, we can see that it's going to cross at that point right there. So this purple line on the left-hand side is y is equal to 9 to the exponent x. Next, we'll take a look here. We've got y is equal to 20 times 4 to the x. So it's going to have a y-intercept of 20. So here we have a y-intercept of 20. And we know that it's going to increase quite rapidly based on uh, the fact that you're multiplying the base value by 20. And in fact, this red line happens to be that equation. So y is equal to 20 times 4 to the x. So now that leaves us with these two examples on the right-hand side. So here we know that the b value is going to be less, for both of them, is going to be less than 1. So it's going to be decreasing. So obviously it's got to be one of the two in the middle. So we also know that the a value is 1 for both of them. And so as we go through, let's take a look at if we do y is equal to 1/2 to the exponent negative 1, that is actually when y is equal to 2. Because 1/2 to the exponent negative 1 is 2. And so therefore, this red line here must be y is equal to 1/2 to the exponent x. And then finally, we'll do the last example. And that's telling us here y is equal to 1 over 10 to the exponent x. So 1 over 10 to the exponent negative 1 is actually equal to positive 10. So that happens right here. We know that the y-intercept is going to be 1. And so this purple line, this is actually y is equal to 1 over 10 to the exponent x. Okay? So that's one way that we can identify all of the graphs based on the equations.